Welcome back to the Crystal Clear Electronics video series. We have now reached the sixth and final video in this chapter. Béla, how do we conclude this lesson?
We haven't touched on an important question yet. I mentioned earlier that we should not connect the 12 volt power supply to a resistor of just 100 ohms. Why did I ask for this? The reason is the maximum load capacity of the resistor. This value depends on the type and design of the resistor. The load capacity of small through-hole resistors is mainly dependent on the physical size, usually between 0.25 to 1 watts. Surface-mounted, small-sized resistors have a similar range, while high-performance, so-called power resistors can be much larger, 2, 5, even 10 watts. The resistor converts the absorbed power into heat, which causes it to heat up and transfer some of its heat to the environment. The amount of power which can be transferred in the form of heat depends, amongst other things, on its size and the difference in temperature between the component and its environment. If its surface is small, and still it is exposed to high loads, then it can only transfer this heat if the temperature difference between the component and its environment is greatly increased. Over a given load, the component can become so hot that the resistor itself is damaged and its properties can change, or it can even burn out completely. This is yet another reason why you need to be careful not only when measuring, but also when assembling and operating the circuit. Preliminary calculations and estimates most often eliminate these potential hazards. We will now go through this with an example. In electrical systems, the power absorbed by a component is the product of the voltage on it and the current flowing through it. P equals U times I. Fortunately, there is no need to know both the current and the voltage to calculate the power consumption of the resistors, since Ohm's law gives the ratio of the two. Substituting U equals Ri, or I equals U over R, we get the following expressions. P equals R times I squared, and the equals U squared over R. By observing the formula better, the following statements can be made. The power absorbed by the resistor will be proportional to the square of the current or voltage flowing through it. For example, if the voltage is doubled on the resistor, then the power is not doubled, but quadrupled. It is also worth bearing in mind that with a constant voltage power supply, reducing the resistance increases the performance in inverse proportion. So for example, halving the resistance will double the performance. Let's get a little back in the case of the 100 ohm resistor, when I asked, do not connect the 12 volt power supply on it. In this case, the power absorbed by the resistor would be approximately 1.5 watts. The maximum allowable value for the resistor I use is only 0.6 watts. We should avoid overloading the resistors, since the resistance value, because of the heating, will certainly change, but in most cases, they will also suffer from long-term damage. Pay attention to this when using resistors smaller than 1 kilo ohm. If you need to convert high performance into heat, you can choose between two options. One option is to combine multiple low power resistors. The other is the use of high performance heating resistors manufactured for this purpose. Let's look at an example for the second solution. Build the circuit shown in the figure from a 47 ohm power resistor with a power of 5 watts. Of course, the meter is now also connected in series. Be careful when doing this measurement because of the danger of burn injuries. Before you turn on the power, always calculate how much power will get into the resistor. In our case, if we substitute the previously measured voltage value of 12.2 volts, the calculated power is approximately 3.16 watts.
Közelítőleg 3,16 watt lesz a számolt teljesítmény.
This is less than 5 watts, which is allowable at this resistor, so we can turn on the circuit, but we have to calculate with the fact that the resistor will warm up considerably. Check to see if we've put our component in a place where this may not be a problem. If it is done, we can turn on the circuit. The resistor can rise up to 100 degrees centigrade in a relatively short period of time, and touching can cause burn injuries. As a practice, measure the current but first estimate it.
Meg annak az értékét. Ebben a kapcsolásban
Expected current in this connection, rewritten to our measured 12.2 volts,
miért feszültségértékre a 12,20 voltra az itteni értéket,
we get that the estimated current is going to be around 0.26 amps.
26 ampere lesz.
We can notice that the current in a circuit where the power is high will be high, so we often have to use the previously known 10 amp measurement limit for such circuits. We must do this now as well. I hope, Gergő, you did everything that was needed.
Egy pillanat. Igen.
Let's take a look at our multimeter.
(0.283 amps).
Ampert.
This is not a problem for this instrument, as it has a measuring point of 400 milliamps.
Great! Now we compare these with the values we just calculated, which were 0.26 amps, so we can see that there's a difference of around 2 hundredths.
Század körüli az eltérés.
Before I say goodbye, I would like to show you a little experiment.
Kis kísérlettel, ahogy látjátok itt az asztalon,
On the table is a tool that we have put together for you.
egy fém lemezre
On a metal plate, we glued 44 pieces of 68 ohm resistors.
ellenállást, kettőt sorosan kapcsoltuk,
We connected 2 in series and connected them in parallel. Then, we connected 30 volts to this network using our lab power supply.
ha kiszámoljuk, akkor az eredő ellenállás
If we calculate, the resultant resistance is about 6.18 ohms. Our measured value was around 6.7 ohms.
7 ohm körüli érték volt, és ennek kapcsán azt is megállapítottuk, hogy
So we found that we have about 140 watts of power that is now operating in this system. Let's look at what this 140 watts might be enough for. Gergő, please help me.
Thanks.
voilà.
And here, our egg has started to cook.
Hát ebből is
You can see that this is a pretty high temperature. This is to show you to always be aware and be very careful.
remélem, hogy
I hope this chapter assists in safely and carefully operating the circuits assembled at home, ensuring the safety of oneself and the equipment.
Thank you, Béla, for being with us in this episode. And thank you also for being with us in the chapter Multimeter Ohm's Law in Practice. We hope that using multimeters won't be a problem in the future and that you will not shy away from complex resistor networks. The curriculum can be downloaded in PDF format from crystalclearelectronics.eu or in Hungarian from kristálytisztaelektronika.hu. The mobile application can be downloaded under the same name for the Android and iOS platforms. Follow our Facebook page where we share news about the project, and see you in the next video. Bye bye!
Goodbye!